If you were asked to find the pH of a 0.01 molar ammonium chloride solution, right, the first thing would be to decide, does anything here act as an acid or a base? So all ammonium salts are soluble. When you put this in water, you get ammonium ions and chloride ions. Chloride has a negative charge. It looks like it could attract a hydrogen ion from water. But if chloride attracted a hydrogen ion from water, you'd get hydrochloric acid. All right? We know that hydrochloric acid dissociates 100% in water. This is not going to reform in solution, so this reaction's not going to happen. Chloride does not act as a base to any measurable extent. This species is going to give you a neutral solution. But how about the ammonium? All right? Ammonium, it's the conjugate base of it's the conjugate acid of a weak base. You can see that it has an extra hydrogen. It has a hydrogen that it can donate in water. And so it can act as a weak base by donating that hydrogen and giving you back ammonia. All right? So this is great. This can act as an acid. And if you wanted to find the pH of this solution, you'd have to treat this as a weak acid equilibrium. And that's something we're going to talk about a lot more on Wednesday. But the first thing you would need is an equilibrium constant for this reaction. And if you look in tables, you will not find an Ka for the ammonium ion. But you will find a Kb for ammonia. And that's 1.8 times 10 to the negative fifth. All right, and so you can use that Kb to find what you really want, which is a Ka for this acid. All right, we know that Ka times Kb equals Kw. So we can rearrange this, say Ka equals Kw over Kb. At 25 degrees Celsius, Kw is always 1.0 times 10 to the negative 14th. And I gave you a Kb value. And so the Ka here, the Ka of the ammonium ion, is 5.6 times 10 to the negative 10th. Right? And so then we can use, next class, we'll use numbers like this to actually find pH of a weak acid.